I look like a boy. It's a strong button.
All right, so this will be in Schoology, so listen up. I'm going to first do these. Second, I'm going to explain Roman numerals. Third, I'm going to show you how to do covalent. And guess what? Naming covalent and writing formulas for covalent, super easy. Okay? So I'll do the easy at the end because you get the heavy first. So check this out. For naming, use your yellow periodic table that has ions on there. If it's a single atom, look in the periodic table. If it's something that has more than one atom, more than one element, then it's going to be one of those polyatomic ones, and that will be either on top, front of the yellow, or on the back, right? So we have sodium, because that's Na. What's NO3? What's NO3? Look it up. What's NO3? Nitrate. That's it. Okay, good. NH4 is a polyatomic ion. What's that? The A word, ammonium. What's PO4? Another polyatomic? Phosphate. Good. Okay. Then you have, look at this one. Very similar. You get PbCN2 and PbCN4. So you know that they both will be lead. I'm going to leave a space. Cn is a polyatomic ion called what? Did you find it? Cyanide. And this one's lead cyanide. So obviously something's wrong here because it's not the same compound, right? It's PbCN, but it's 2 and 4. That's a different compound. Kind of similar. A good analogy is CO and CO2, right? Carbon monoxide and carbon dioxide, two different compounds. These are ionic, but they're two different compounds. So this is where you use the Roman numeral. Look under lead in the yellow periodic table. Notice how lead can have two ions, either lead 2 plus or lead 4 plus. So for those, the charge becomes the Roman numeral. You guys with me?
Yep.
So this is lead, parentheses 2 cyanide, and this is lead, parentheses 4 cyanide. So that's how Roman numerals are used. They're only used for the metals that have more than one possible charge. Okay? So 2 and 4. Sometimes the subscript will be the same, but it's not about the subscript. It's this 2 is not that 2 necessarily. This 4 is not that 4 necessarily. It's the actual charge. So if you look in the periodic table, the yellow one, you'll have Pb2 plus and Pb4 plus in the lead box, right? It's something like that. So 2 plus, that's the 2. 4 plus, that's the 4. And this will be kind of apparent here. All right, formulas. Magnesium dichromate. So again, you got to do it where you go find the charge, Mg2 plus. And then dichromate is what? Cr2O7 2 negative, right? Right? This is on the back, or maybe on the front too. So 2 and 2 cancel out, so you can just drop the charges, and it will simply be MgCr2O7. Is that what you have? Okay. Now, sodium nitrite, Na plus, and nitrite is NO3 what? Negative. So again, same but opposite charge, they just cancel out. So the formula will simply be NaNO3. Okay? Right? Let me correct that. All right, moving on. Now again, notice iron oxide, but it's different iron. Look in the box for Fe, iron. So you got Fe, 2 tells me that it's the 2 plus one, right? And then for the iron 3, it tells me it's Fe3 plus. And then oxide is always what? 2 negative, 2 negative. So doing the crisscross method, for the first one, the 2's will simply cancel out, FeO, right? Hey, you might learn something. So, and then 2 and 3, so we get Fe2O3. So again, this is how Roman numerals are used. Roman numerals are the charge of the metal ion. Okay? Roman numerals are the charge of the metal ions. Okay? Good. This is recording, I think. Hope. So, okay. Now, what you guys will do to practice, you can finish the rest of that worksheet in, not Google Classroom, but Schoology. Thank you. But let me quickly explain ionic because it's easy. Here's what you got to know for ionic. Okay? And I will give you these on the test. But for, not ionic, covalent, sorry. For covalent, we use what's called prefixes. Prefixes. What are prefixes? Prefixes, the words that come before the name of the element. So, 1 is mono, 2 is di, tri, tetra, penta, hexa, hepta. You already know octa from Octomom, right? Nona and deca. No, octet rule. Octomom, octopus, whatever. Octo something. Right? So, you got that? Feel free to take a picture. But, let's do a few examples so you see how this works. I'll do maybe 2 from the first 5 and 2 from the bottom, and then I'll have you finish the rest of them yourself. So, check this out. Is this showing? Yeah, it is. Good. Let's move the camera a little bit. All right, so, how about this? Let's do 3, because that's a fun one. Right? You guys, one thing you got to know, mono stands for 1. You don't use mono on the first element. So for number 3 here, xenon, I would not call this monoxenon. I just call it simply xenon. It's very similar, again, the example of carbon dioxide and carbon monoxide. See how I don't say monocarbon monoxide? I just say carbon monoxide. So you only use mono on the second element. Got it? You never use it. I wouldn't call this monocarbon dioxide. I call this carbon dioxide. So, okay, that's the only thing you got to remember that's an exception. Anyway, so this is xenon. And what's 6? What's 6? Hexa. So this is xenon. Get this, hexafluoride. So basically you're saying 1 xenon, 6 fluorines. So the ending is still IDE for the second one, like it was in ionic, but you use the prefixes, that's how you know it's covalent. Xenon, hexafluoride. Okay, how about, let's do this bad boy here. What's P2O5? What's 2? What's 2? What's 2? Prefix. Di. What? What's P? Diphosphorus. And what's 5? Pentagon, right? Pentaoxide. Now check this out. Pentaoxide is kind of awkward to say. You drop the ending of the prefix and just call it pentoxide. Get what I'm saying? So it rolls off the tongue. Instead of pentaoxide, you say pentoxide. Okay? Now, if you do that on a quiz or something, I'm not going to worry about it. If you say, I just need you to know it. But that's the convention, so I want you to be aware of it. Okay, let's do these. These, you do the same thing backwards. Silicon, so it tells me it's just 1 Si, because it doesn't say di or anything, right? Dioxide tells me what? 2O, so O2. So the di, that always goes for this one, don't confuse it with it, Si2O, it's SiO2 because it's dioxide, 2 oxygen. Okay, how about, let's do this one. Tetraphosphorus, so what is that? Phosphorus is what? P. Tetra stands for 4, so P4. Decoxide, so what's deca? 10. What's oxide? So O what? Does that make sense? Covalence easy. My son would say he's 4, almost 5. New Year's baby. Easy peasy lemon squeezy, right? But you know. Kids do that. It's cute, isn't it? If I say that, not so cute. When my kid says it, cute as heck. Okay, this is being recorded, so I cannot say the other word, but, okay, so, 2 things you got to do today are, 1, finish the Schoology worksheet that I put in there Monday, and do the leftover 6 or however many, so you get some practice with that. Tomorrow, and for the next 2 days, I'll give you like a big worksheet that has ionic on one side, covalent on the other, so you can work over next 2 days and feel good about it. And I'll give you a key, right? Right? Okay. All right.